Everything is ready. I have compiled the code, and I see that in this bin directory that also the developers have built, so this is specific for this software. If you download another software, things will not necessarily be like that. There is this raxml command. So in order to execute it, I need to specify the directory that I executed. Since I'm inside the bin, I need to put /raxml. And the program runs. Of course, I haven't provided input file, so it will not do anything interesting here. It will just print out the help. So what I want to mention here is, if I am in another directory, for example, in this test directory, and I want to run, so I make a directory analysis, and I go to inside the analysis, and in this directory now I want to run the raxml, I must specify the location of raxml. And this is, of course, one level up, and then software, and then raxml, and then bin, and then raxml. So in order to run raxml, I must specify the address relatively or absolutely of the software itself. Now another way is to put this raxml within the what we call path, within the path directory. So there is a specific variable called path. In order to see its value, I must use the echo command, which will print out something in the monitor. So for example, if I use echo this one, it will just print out fdfd. And there is a variable called path, like that. But if I want to get its value, I must use the $sign in the beginning. So this is the name of the variable, and this is the value of the variable. And then it's this file here, this set of files. So this is one file, this is a second file, and this is a third file, and so on. Why this path is useful? Whenever we run a command like ls, the system goes in each of these directories and searches for the command ls. So it goes here, it will not find it, it goes here in the second one, it will not find it, it goes in the third one, it will not find it, it goes to the fourth one, it will not find it, it goes in every one. If it will not find it anywhere, for example, if I will press the command this one, it will just report that command not found. But if this command is somewhere, it will execute it. So if I will press which ls, it will inform me that it's the ls within the user bin. Indeed, the user bin is in the path, so that's how Linux found the ls command. Now the solution is simple. What I have to do is to put the raxml within the path within a path folder. If I will just type again echo path, I will see that in the only folder that I have access as a student user is actually this home student bin, because this bin is inside the home folder of student, and I have a write permission here. So what I can do, I will show in another lecture how to modify the path and put something, a new folder there. I will copy the raxml, the executable, which is here, inside the bin folder of the home directory. The shortcut is this one, right? The tilde means the home directory of the current user, which is student. So this is /home/student and then /bin. And now I can run raxml-ng from any folder that I am. Why? Because typing raxml-ng, it will go in each one of these directories here of the path sequentially, so it will go to the first one, it will find it actually, and then it will execute it. Okay, so raxml-ng, and then I must, okay, I will use probably a ready command here, so this one, yeah, this one. So raxml-ng, I will specify the multiple sequence alignment and say that it is in the data folder, and then ALN, remember the ALN is the aligned file, not the FA, and then -- model GTR plus gamma. You don't need to pay attention now to all these details here. So this model is the evolutionary model that I will use to build the phylogenetic tree, and if I'm lucky enough, pressing enter, it will build the phylogenetic tree. Indeed, raxml informs us that it needed 3.2 seconds for that and consumed 0.17 watts for that. But yeah, okay, if I would do a less now, I don't see anything, and the reason is that raxml uses this prefix for the output data, so everything should be inside the data. Yeah. So it was a bit unlucky that I used this analysis folder, because eventually raxml put everything inside here. Okay, and the tree, the phylogenetic tree of the analysis, is actually this best tree. Okay, one time to write more. This is the tree in UIC format. Let's see where human is. Or maybe I can actually view it using the figtree command, which is pre-installed here, but it's easy to install it using the sudo apt install figtree. Let's see if it will open. Yeah. Okay, and see, this chimp, this human here. So human is close enough with chimps and so on. Okay, the data is a bit small, so maybe the resolution that we obtained in this tree is not so good. Okay, that's for the moment. I hope the class was useful. Oh, okay. Yeah, let's put everything, before leaving, let's put everything within the script. So this is the grep, this is the download, this is the math command. I assume that I manually download and compile the software and put everything in the proper directories in the path. I say manually because sometimes this is specific to the file system of each user, so the directories might be user specific. And then, assuming that I have installed raxml, let's see what command I need. Yeah, this one. I need to modify it actually. So this is in this directory. Okay, now if I run this command, it will do the whole process. Make directory first, and then download the data, go inside the data folder, get the part of the alignment that we want, and remove all the unnecessary things, and then it will unalign them also, so removing the dashes, the alignment dashes here. align them again. Actually, this step I said before that's not necessary because we can actually download the data already aligned. I just want to demonstrate how to align the data, and then use raxml in the aligned data, and that's it. Now the benefit of this process is that if you want to repeat this analysis for another gene, you just have to change the motif here. And if you want to share this work with another researcher, you can just give him the script and he will be able to check that everything you did is correct and to repeat the analysis for himself or another gene. So sharing is good, reproducibility is good. So please write your pipelines in scripts. At least the simple pipelines. For more complicated, there are other ways as well. Thanks a lot.